Hello! Welcome to 3.5 Combining Functions. Here we go. So we talked about functions briefly before. The biggest thing is the input is what goes in, the output is what comes out, and order will start to matter. So we're going to take the first couple slow, and then we'll see how you do. So we have two functions here. F of x equals 3x plus 1, and g of x equals x minus 1. We're going to find the domain of each of these, a, b, c, and d, and compute the following. So, looking at this, the first one says f plus g of x. That's how you read it. In other words, it's going to be f of x plus the g of x. That is a true statement. You can break them up separately. So that just means you replace g of x here, you replace f of x here, and then we'll combine like terms. So the first function, f of x, is 3x plus 1. The second function, g of x, is just x minus 1. Just took those two parts, and do a lot of highlighting today, my dears, and now I'm just going to add them together. Combining like terms, I will get 4x will be my answer. My domain, there is no restriction on this. These are lines, you add it, you get 4x. So the domain you can write just for all reals. All real x's even. All real x, whatever you want. Looking at the next one, it's f minus g of x. That just means you take your f of x function, subtract your g of x function. So your g of x is here, f of x is here. Let's plug it in. So you get 3x plus 1. But this time you're subtracting x minus 1, right? You're taking away the g of x function. When you do so, don't forget to distribute. So you end up with 3x plus 1 minus x plus 1. So this will be 2x plus 2. That is what happens when you subtract the two functions. Again, there's no restriction on this x, so domain all real x. Hopefully you're getting the hang of it. The next one is f times g of x, which means equivalent to taking f of x and multiplying it by g of x. So you're going to take 3x plus 1 and multiply it by x minus 1. Get to do some fun foiling. We love to foil. You will get 3x squared minus 3x plus x minus 1. Combine your like terms. And that's what you would get if you multiplied the two. No restriction. All real x. Last one is now division. You're going to take your f of x and divide it by the g of x. Now, this is something we have to be careful of. We have to remember denominators cannot be 0. So whatever we get, we need to know that denominator cannot be 0. Writing the two functions, I get 3x plus 1 in the numerator, x minus 1 in the denominator. There's no GCF, nothing to be able to cancel, so this is actually my final answer. but this time there will be a domain restriction. Since the bottom can't be 0, that means I can be all real x except x cannot equal 1. Because if it was 1, the denominator would be 0. Okay, so it's just taking it slow, matching up your functions. And now we're going to talk about the next operation in a way. This is not multiplication. This symbol, I'm going to write it even in red, not multiplication. Okay, multiplication will be right next to each other or like the little asterisk. This is called f of g compared to g of f. We have our two functions here. The first one is f of x equals x squared. The next one is g of x equals 3x plus 1. We're going to compute these two problems and compare them. Because we know, like, when you multiply, it doesn't matter the order. When you add, it doesn't matter the order. But in this case, when you do f of g or g of f, you're going to see that actually order is going to matter. Let's take it piece by piece. Looking at just the first one here. F of g of x. That's telling me I'm going to take the g function and plug it into the f function. That's what that little open circle tells me. So I'm taking the g function and plugging it into the f function. So here is my g function in the parentheses. I'm putting it into the f. That means wherever I see an x now, I have 3x plus 1. Well, in the yellow function, the x is squared. So let's make sure we square it. We do our foiling. This is the answer if you did f of g of x. Now let's look at the other one. What if this time I took the f function and plugged it into the g function? So here's my f function. It's going to go into my g function. F is just x squared, plugging it in to my g function. So that means wherever I see an x in my green, I'm going to put x squared. That's exactly what I just did. Then I just need to simplify, and this is what I get. So something huge to note, when you compute this, put this to the side, order matters. Very important. Okay, whichever one is being plugged into the other will change the answer. Now we're actually going to talk about two ways to compute the composite function. So right here, this is the composite. Remember I told you it's not multiplication, but the input was just x. Now we're going to talk about it if the composite inside is a number. In this case, -2. There will be two ways to talk about it. Again, we still have our same f function, same g function, but notice the difference is now there's a value. First way you can solve this is take f of g of x, like normal, like exactly what we did above, And then at the very end, substitute in the -2. So I'm going to go through this one. It's just like the one we did above. It means I'm going to take the G, plug it into the F. So I'm taking G, plugging it into F. What is G? It's 3x plus 1. So that means wherever I see an x in the f function, I'm going to replace it with 3x plus 1. So here, the first value is just x squared, so it's 3x plus 1 squared. FOIL that little one, you'll get 9x squared plus 6x plus 1. Now that you're here, you're going to go, you're going to first have enough room, because I write like a giant. You're now going to take that function and plug in a -2. So treat this pretty much like its own function. Wherever I see an x now, I'm going to put a -2. So it's 9 times -2 squared plus 6 times -2 minus 1, because this is my new input. When you simplify, you should get 36 minus 12 minus 1, 25. And that is the first way to think of it. Do f of g of x, then do your input at the end. The second way, I don't know why I had to say it twice, but we'll make it through, is to input it right away. Normally, we just write f of g of x. Right, I'm taking the g function, plugging it in. But this time, you're actually going to plug in the -2 to the g, then that outcome to the f. Really think of like inside out. Work your way in, work your way out. So if I'm plugging in a -2 to the g function. Well, here's my g function. Remember, it's green. So instead of x, put that -2. Simplify, I get -5. Now, -5 goes into my f function. Well, instead of x, put -5. That's the yellow function. And voila, I still get 25. Okay, so you pick which way works best for you. Maybe in a different problem with different functions, you'll pick a different way. It's up to you. Okay, we now have a couple more with a bunch of different functions. I want you to quickly pause the video. I would like you to try these on your own first. Okay, hopefully you paused the video. Let's go through these now. It's important to stay organized. I'm looking at the f of 2. That means right here, I'm inputting a 2. So I'm going to look at that. It means a 2 goes here. That's 4 minus 1. That's 3. Then I'm taking away g of 2. Well, here's the g function. I'm going to do a nice parenthesis. I'm going to take away 2 of that, like input a 2. So it's going to be 2 squared minus 3 times 2 minus 6. That's 4 minus 6 minus 6. You're going to be subtracting a -8. So hopefully you got 11. Next one is g of f of x. You're going to take f of x and replace it into the g. It's going to look like g of f of f of x, right? We're taking that whole function and putting it inside. Well, the f function is normally 2x minus 1, which means everywhere I see an x in the g function, and now I have to replace it with 2x minus 1. A little messy, but we can do it. Okay, I'm at my g function. I see an x. Nope, no longer do I just put an x. I have to put 2x minus 1. Square it. See an x. Let's put that 2x minus 1. Hopefully you did this foiling. 4x squared minus 4x plus 1. Distribute. I'm getting 4x squared minus 10x minus 2. Again, if I'm going too fast, look back at yours or pause, because you should have tried these first. We now have g of 3. So that is like up here you have two options either way to solve these, because it's a composite. So what I'm going to do is rewrite it as g of 3. G of 3 means I take my g function, which is, sorry about that, I need to see it, right there, and plug in a 3 everywhere I see an x. So this would be 3 squared minus 3 times 3 minus 6. So I'm just working inside, right? I'm just doing the g of 3. So it's 9 minus 6. So, just negative 6. I'm working my way out. Now I can plug in negative 6 to my g function. That's what this is telling me. So wherever I normally saw an x in the g function, I put a negative 6. So I would get 36 plus 18 minus 6, 48. Again, that's just one way. If you prefer the other, go for it. Another composite. Take the h function, plug it into the m function. So it's m of h of x. What is h of x? Is x cubed. That means really you're plugging an x cubed into m. The m function is x squared minus 9. So now it's x cubed squared minus 9. Man, that looks weird. But we know our power rules. Power to a power u, multiply x to the 6 minus 9. So please pause, try these again, look at what I did, make sure you understand what to correct. Moving on to our last part, we're going to refer to graphs now. So instead of me giving you a function like 2x minus 1, I'm giving you a graph to look at. Look at inputs and outputs. We're going to start inside out. That's our motto. I'm going to start with g of 2. If I go to my g function, and here's my f, my g, my h. If I go to my g function and input a 2, what comes out is a 1, that y value. So I'm going to rewrite this as f of 1. So now I go to my f function. If I plug in 1, what comes out? Well, that would be 0. Number 2, start inside out. If I plugged in a 3 to my f function, here's my f, 1, 2, 3. What comes out? point right here, which is a 4. So I'm just going to rewrite now. Working my way out, I now have h of 4. Go to my h function. If I plug in 4, I get out 0. Go to my h function. Again, we're doing number 3. Plug in 3. So in h, plug in 3. What comes out is 2. Working my way out, I'm now f of 2. So go to your f function. If I plug in 2, what comes out is -1. This last one, number 4, I'm going to leave for you. You can do it. I believe in you. You will have one extra step, but you're going to work inside out. Write it in red. Inside out. Please be ready to all show me number 4 when you come to class. Good luck, my dears.